Okay, now let's look at question number 15, part C. So in part C, it is given k is positive and x values are also positive. Then we have to show that this derivative of this function is equal to this. So if you look at the function, we have to differentiate. It's a product, u times v. So we can apply the product rule to find the derivative. So let's apply the product rule and quickly find the appropriate expression. So keep k square root x minus 1 and find the derivative of e to the k square root x. So that is going to be e to the k square root x times k over 2 times square root x, plus we keep e to the k square root x and find the derivative of the other term. So that is going to be k over 2 root x, right? So then let's get rid of, so let's take the common part out. Common part of this is what? This term is common for both terms, so we can take that out. E k square root x times k over 2 square root x. Then what is left? K square root x minus 1 plus 1. So this cancels. You get k squared e to the k square root x over 2 square root x. So square root x cancels. K squared over 2 e to the k square root x. That is what we wanted to show. So first part is done. Then the second part of the question is we have to show this definite integral is equal to this expression, right? So we will use the first part to get this. We know d over dx k square root x minus 1 e to the k square root x is equal to k squared over 2 e to the k square root x. So now take the integral of both sides with respect to x. Then what happens to the left hand side? Left hand side you get k square root x minus 1 times e k square root x dx. Sorry, not dx, just e square root x. And on the right hand side you can take the k squared over 2 out and you get e k square root x dx. So now we have found the expression for the integral of e to the k square root x dx, which is what? 2 over k squared times k root x minus 1 times e to the k square root x. So now we can find the definite integral using this. So let's apply the limits 4 and 1. When we apply 4, you get 2 over k squared We are applying the limit to variable x. Remember, variable x. So square root 4 is 2. So 2k minus 1 e 2k minus apply the lower limit 1. So you get k minus 1 e to the square root x, which is what we wanted to show. So ik is equal to that. Right. So then, so this should be k. Square root x is 1, so e to the k. Right. Now let's look at the next part. So next part says we have to find the area enclosed by y equals e to the square root x equals 1, x equals 4, and y equals 0. So area S is then going to be what? E to the square root x dx integrated from x equals 1 to x equals 4. This is actually what? From the previous part, we know area S is then going to be equal to I1 because k is equal to 1 in this question, this integral. So if you put k equals 1, we have the answer here. So area S is I1, so that is going to be 2 over 1 squared. Apply k equals 1 to ik expression. So you get 2 times 1 e squared minus 1 minus 1 e to the 1. So you are left with 2 e squared. So that is the answer we were looking for. Right. Then the final part of the question is find the volume of the solid generated by rotating region S, the region S that we found in the previous part, about x-axis through 2 pi radians. So then the volume is given by pi e to the square root x square dx from 1 to 4. So then you can take pi out, then this is 1 to 4 e to 2 root x dx. So volume is what? Pi times I2. So this is k equals 2k. So then let's find I2 by plug in k equals 2 here. So you get pi times 2 over 2 squared 2k, so 4 minus 1 e to the fourth k is 2 now, so e2k becomes 4, e to the 4 minus k is 2 minus 1 e square. So simplify this, 5 over 2 3 times e to the 4 minus e square. So that is the required volume, right? So that is the answer for question number 15 part C.